I am Rainy Marie Camboya from BSIT Mossi. I'm going to talk about different kind of structures. First, array. Array is a collection of variables of the same data type stored together in a single block of memory. It lets you store multiple values under one name and access them using an index number, perfect for storing lists of data. Let's proceed to the code. We're gonna use float as our data type. It means the array will store numbers with decimal points, and grades will be the name of the array. We use this name to refer to all the values stored inside it. Sub 5 is the size of the array. It means the array can store exactly 5 values, and these values are 92.5, 87.0, 78.5, 95.0, and 67.5. For the loop, we will have the loop run 5 times. Inside the loop, I plus 1 is used because we want to display grade 1, grade 2, etc. instead of starting from 0. Grade sub 1 accesses the value at position I in the array, and line moves to a new line after each output. Next, struct. Struct or structure is a custom data type that groups different kinds of data together into one unit. Instead of having separate variables, we put them all inside one struct. This makes data organized and easier to manage. Let's proceed to code. Struct student. This tells the program I want to create a new data type called student. Inside the curly braces, we list the members or attributes that makes up this type. Int ID stores a whole number like student ID numbers. String name stores text or names. Float grade stores numbers with decimal points, like grades 92.5, 87.0, etc. Why do we use struct? Instead of creating separate variables like in student ID, string student name, and float student grade, we put them all together in one place. This keeps related information organized and makes it easier to manage, especially when working with many records. Now that we have defined the student type, we can create variables that use this type. S1 is the name of our variable. It is like a container that can hold all the information for one student. Just like we declare int number or string text, here we declare student S1 to create a student record. In assigning values to members, to put data inside the struct, we use the dot operator. The format is variable name dot member name equals value semicolon. S1.id equals 101 semicolon. It sets the ID value of student S1 to 101. S1.name equals Ana Cruz. Sets the name value to the text Ana Cruz. S1.grade equals 92.5. Sets the grade value to 92.5. In displaying the data, we use cout to print the values stored in the struct. Again, we use the dot operator to access each member. S1.id gets the ID number. S1.name gets the name text. S1.grade gets the grade number. And end line moves to a new line after each output, so the information is easy to read. Let's proceed to enum. Enum stands for enumeration. It is a special data type that lets you create your own set of named constant values. These values represent fixed options or categories. How does it work in this code? We created a new type called standing. This type can only hold one of the values listed inside the curly braces. Each name inside the enum is automatically assigned an integer value, starting from 0 by default. Excellent equals 0, good equals 1, satisfactory equals 2, failed equals 3. Even though these are numbers, we use the names instead because they are easier to read and understand. Why do we use enum? Instead of using numbers like 0, 1, 2, 3 in our code, we use clear words like excellent or failed. This makes the code easier to read, less confusing, and helps prevent mistakes. Anyone looking at the code will immediately know what each value means. Now that we have defined the standing type, we can create variables of this type. Result 1 is a variable of type standing, and we assign it to the value excellent. Result 2 is another variable of type standing, and we assign it to the value failed. Even though behind the scenes, these are stored as numbers, 0 and 3, we use the names to make our code clearer. We can use enum values in if statements and comparisons, just like we use numbers or text. First condition is we check if result 1 is equal to excellent. Since we set result 1 to excellent, the condition is true. So it prints the message, this student has high honors. The second condition, we check if result 2 is equal to fail. Since we set result 2 to fail, this condition is also true. So it prints, this student needs to retake the subject. Last but definitely not the least, bubble sorting. What is bubble sort? Bubble sort is a simple sorting algorithm that works by repeatedly comparing pairs of items next to each other. If they are in the wrong order, it swaps them. This process repeats until the whole list is sorted, just like bubbles rising to the top of water. Void bubble sort. This is a function that takes two things, student list and the int size. Student list is the array of student records that we want to sort, and int size is the total number of records in the array. The void means this function does not return any value. It just changes the original array. In the outer loop, this loop controls how many times we go through the list. I starts at 0 and runs until it is less than size minus 1. We don't need to loop up to the last element because once we move other items, the last element will already be in the correct place. The inner loop. This loop goes through the list and compares adjacent items, item at position j and item at position j plus 1. Size minus I minus 1. As we sort more items, the end of the list becomes already sorted, so we don't need to check those again. This makes the process faster. This sub j.name is greater than this sub j plus 1.name. This checks if the name at position j comes after the name at position j plus 1 in the alphabet. Example, Ben comes after Anna, so Ben is greater than Anna is true. If the condition is true, it means they are in the wrong order, so we swap them. How does swapping works? Student temp equals list sub j, semicolon. We save the first item in a temporary container called temp. This sub j is equals to this sub j plus 1. We put the second item into the first position. This sub j plus 1 equals temp. We put the saved first item into the second position. After swapping, the two items are now in the correct order. We create an array called student that holds 3 student records. The initial order is Ben, grade is 85.0, Anna, grade 92.5, and Carl, grade 78.0. We call the bubble sort function and give it our array and its size 3. Now the function will rearrange the records in alphabetical order by name. We use a loop to print each record after sorting. We show both the name and grade so we can see the result clearly.